A recruiter reaches out. The job sounds interesting and the pay is excellent. The recruiter sends you a coding challenge as part of the interview process. You download the project from GitHub and open it up. You've just installed North Korean malware and they've stolen all your passwords and cryptocurrency. Security researchers have tracked North Korean linked fake interview campaigns that use this exact method for years. In this investigation, we're hunting for live North Korean fake interview campaigns. We can't search for the name of the malware. They constantly upload and delete these fake interview challenges, changing the names each time. Instead, we can look for consistent behavior. We look for signs the project might quietly run something when a developer opens it. Typically, the code on GitHub doesn't do the bad action. It just downloads the thing that does. Typically, these campaigns store this bad code on a website called Vercel. And before it downloads the code, it will check if you're running Windows, Mac, or Linux in order to give you the right version of the bad code. So let's start there. In GitHub, we're looking for code that mentions Mac, Linux, and Windows, and Vercel all on the same page. As you can see, there are quite a few projects that fit this pattern, lots of which look suspicious. Opening up one of these, we have a GitHub project presenting itself as a StockX coding challenge. At first glance, it looks like a lot of the other test projects, but there was a hidden path in the code that looks really suspicious. Visual Code Studio is one of the most common developer tools. It can run tasks automatically when a project folder is opened. So if you open the project, Visual Code Studio runs a task. This runs a hidden script in the background that reaches out to a website that is tanxilabs.com. Suspicious code is one thing, but proving what it does is another. When this was run on my computer, it downloaded JavaScript code. The code I captured showed behavior consistent with an information stealer. It looked for saved login data and then hunted for cryptocurrency files. Then it tried to send collected data to servers that were controlled by the attacker. Once we confirmed this project was malicious, the next question was, how is it being distributed? GitHub keeps file histories, and that history can show who added code, when they added it, and what name or email address was attached. In the first file creation for the StockX code, we can see an email address related to linkxlabs.com. This doesn't mean linkxlabs is malicious, because email addresses could be stolen and then used for malicious purposes. But it is a clue. So let's follow it. Next, I looked up linkxlabs.com. There was a website and there was a LinkedIn company page. There were many employee profiles and jobs advertised with contact details. On the surface, it looks like a real technology company, but several things were unusual. All the activity that I found was very recent, including the website's registration itself. This contradicts the claims that they'd been operating for 7 years. The LinkedIn employee data was also off, with several profiles showing staff at LinkX Labs holding roles at other organizations at the same time. There was also mismatched founder information between the LinkedIn employee profiles and what was listed on the website. One employee stood out as the most active poster on LinkedIn, working for only LinkX with a custom banner on their LinkedIn profile. This was for their head recruiter, Anna. From LinkX, I also looked for related websites. At the bottom of their webpage, they have the text, "Built with love for the future of technology." That phrase is unusually specific. Searching that in Google, there were only 2 other results, techchainai.com and foisys.com. After discovering those websites, I then returned to GitHub. 2 other findings that we can make from the GitHub file history. The threat actor uses Claude, and they'd used Claude to add a public demo of the project, likely to show the job candidate how it works and how to run it. More interesting still, there was one more contributor to this project, and looking through their GitHub profile, we can see a fresh set of coding challenges on GitHub had been recently updated. One was only 4 hours old. They were all assessments for different programming languages. At this point, I expected to find the same methods as before, searching the code for bad web addresses, but that was not what I found. There were no hidden Visual Studio tasks. There was no Tanksy Labs address. Instead, the attacker was changing their tactics. They didn't just list the web address in the code as they did before. It was now deeper and encoded. The new trigger was simpler and no longer relied on the victim using Visual Studio. It performed the download when they ran the coding test. Looking at one of the coding challenges for the Node programming language, we can go deeper. We can find a value labeled dev API key hidden in the code, but it actually contained an encoded web address. When we decode this, it becomes ipregionchecker.org. When the IP region checker server responds with JavaScript, it's automatically run on the victim's computer. So even though the first changed, the end goal worked the same. Find valuable data, package it up, and send it out. I found the same hidden IP region checker used across multiple fresh GitHub projects. While the attackers are shifting their approach, it is hard to completely reimagine an attack each time, so there's often overlap that enables hunting and linking between these campaigns.